In the hushed archives of natural history, stories lie waiting. They are tucked away in dusty journals and captured on grainy, flickering film. Here, we find a curious entry from 1935. It is a field note from a pioneering biologist, Dr. Evelyn Reed. Her handwriting, though faded, is filled with a sense of wonder and disbelief. She describes a creature she calls a ghost on the cliff face. It moves with an impossible grace, a phantom against the sheer rock. It shows a white form, almost ethereal, scaling a vertical wall of stone. The creature seems to float upwards, defying the very laws we hold to be true. This was one of the earliest documented encounters with the mountain goat in its extreme habitat. For early explorers and scientists, these animals were a puzzle. They appeared in places where no large mammal should be. They were seen perched on ledges barely wide enough for a boot, seemingly relaxed and untroubled by the dizzying drop below. The grainy black and white footage shows them leaping across chasms that would make a seasoned mountaineer pause. How could they do it? The film offers no answers, only more questions. It captures a spectacle that seems to belong more to the world of myth than to the world of science. It is a silent film, yet it speaks volumes about the mysteries of the natural world. These early records are more than just historical curiosities. They are the starting point of our journey. They represent the first attempts to understand an animal that lives on the very edge of possibility. Dr. Reed's notes are filled with sketches. She drew the goat's powerful shoulders and its unique cloven hooves. She wondered about the friction needed, the balance required, the sheer power it would take to propel a body upwards on such a surface. Her questions, written almost a century ago, are the same questions that fascinate us today. She saw what we see, an animal that appears to break the fundamental rules of physics. From these old archives, we will bring the story to life. We will travel from the silent, flickering images of the past to the vibrant, high-definition world of today. We will follow these incredible climbers to the highest peaks and the steepest cliffs. We will use the latest technology to peel back the layers of this biological marvel. The ghost on the cliff face is no longer a distant mystery. Today, we have the tools to understand its secrets. We can finally answer the questions that have puzzled naturalists for generations. This is the story of how an animal conquered the vertical world. So, how do they do it? How does a creature weighing up to 140 kilograms or 300 pounds dance upon near-vertical rock faces? It is a question that challenges our intuition. We understand gravity. It is the force that pulls us down. It keeps our feet firmly on the ground. When we watch a mountain goat, we see an animal that has a different relationship with gravity. They move with a confidence and security that is simply breathtaking. Not just surviving in extreme environments, they are thriving. They've mastered a world hostile to almost every other living thing. To answer this, we must become detectives, investigate from every angle. Biology, physics, history, cutting-edge science. We'll go deep into the goat's anatomy, explore the hidden architecture of its hooves. Hooves that act not as feet, but as all-terrain climbing gear. Examine the immense power in their muscles, and the extraordinary elasticity of their tendons. A story of biomechanical perfection, honed over millennia. Every part of the goat's body is a piece of the puzzle, but anatomy is only half the story. The other half is physics. We'll explore forces on steep slopes, friction, the force that prevents slipping, center of mass, and how goats manipulate it to stay balanced. A delicate dance of numbers and angles. One miscalculation could be fatal. We'll use graphics and slow-motion footage to make invisible forces visible. See how slope angle changes climbing physics, and how the goat's body solves these equations in real time. A journey of discovery. Spectacular wildlife footage plus rigorous scientific analysis. Archival evidence shows how understanding grew. Modern imaging reveals secrets inside the body. From microtexture of rock to neural signals controlling balance, no stone unturned. Prepare to see mountain goats as never before. Join us as we expose their secrets and answer the question, how do these hooves break physics? To understand the mountain, we must first understand the mountain. Not as a majestic landscape, but as a battlefield of invisible forces. Every object on Earth, including this goat and ourselves, is governed by a set of fundamental physical laws. The most familiar of these is gravity. It is the relentless pull that anchors us to the planet, the force that gives weight to everything. On a flat surface, gravity is simple. It pulls straight down, and the ground pushes straight back up. But on the steep, angled world of a cliff face, the story of gravity becomes far more complex and treacherous. Here, it is not just a downward pull. It is a constant effort to drag everything into the void below. For a climber, whether human or goat, this battlefield is defined by a constant struggle. Gravity is the primary adversary, always working to pull the climber off the rock. To succeed, the climber must generate opposing forces. They must create forces that push them into the cliff and forces that prevent them from sliding down it. It's a dynamic and dangerous equation. Every movement changes the balance of these forces. Every step is a calculation, a shift in weight, a change in posture, the placement of a hand, the placement of a hoof. All these actions manipulate the physics of the situation. The goat's survival depends on mastering this invisible dance. Let's visualize this. Imagine a block resting on a horizontal table. Gravity pulls it down. The table pushes back up with an equal and opposite force. The block stays put. Simple. Now, tilt that table. Gravity still pulls straight down, but the situation has changed dramatically. A component of gravity now acts parallel to the surface, trying to make the block slide. The upward push from the table, what physicists call the normal force, is now reduced. To stay on this slope, the block needs something else, a force to resist the slide. This is where the physics of climbing truly begins. This is the world the mountain goat inhabits every single day. Its life is a continuous series of physics problems, solved in real time with life or death consequences. Their understanding is innate, written into their bodies. In this act, we will become physicists. We will break down the mountain into a set of forces and vectors. We will quantify the challenges and reveal, step by step, how the mountain goat has evolved the perfect physical solutions to not just survive, but to conquer its vertical realm. The ghost on the cliff is about to have its secrets explained by the laws of Newton. If gravity is the villain in our story, then friction is the unsung hero. It is the force that resists motion between two surfaces in contact. It's the grip that allows us to walk without our feet slipping from under us. For a mountain goat on a steep incline, friction is everything. Without sufficient friction, every cliff face would be an impassable, slippery slide. The goat's ability to climb is, in essence, a testament to its ability to maximize this single, crucial force. It is the very foundation of its grip on the world. So, how does friction work? Imagine trying to slide a heavy box across the floor. It takes a push to get it started. That resistance you feel is friction. It is caused by the microscopic imperfections on the two surfaces, the bottom of the box, the floor, interlocking and catching on each other. The strength of this frictional force depends on two main things. First, the nature of the surfaces themselves. Second, it depends on how hard the surfaces are pressed together. The heavier the box, the more friction it generates. This is where the mountain goat's story gets interesting. Its entire existence is a masterclass in generating friction. The surfaces in its environment are varied: granite, shale, limestone. And the goat's tool for interacting with these surfaces is its hoof. This is no simple solid block. As we will see later, it is an engineering marvel designed to interface with rock on a microscopic level. The goat needs to generate enough static friction, the friction that prevents an object from starting to move, to hold its entire body weight on a tiny, precarious foothold. Every step is a calculated placement to ensure this force is strong enough. The simple equation for the maximum force of static friction is F friction, Cha-Mn. Don't worry about the symbols. It just means the force of friction is less than or equal to a special number called the coefficient of friction, m, multiplied by the normal force, n. The goat's challenge is to ensure that the downward pull of gravity along the slope never exceeds this value. If it does, the hoof slips. The magic of the mountain goat is its incredible ability to keep the force of gravity on the losing side of this equation. We've talked a lot about forces and angles, but it all comes down to one critical moment: the contact between the hoof and the rock. To the casual observer, it might look like any other hoof, but closer inspection shows a complex, multi-component tool, far more sophisticated than the simple hooves of a horse or a deer. Each feature solves a mountain problem, a perfect blend of materials for grip and durability. The hoof's most striking feature is its construction. Two distinct parts working in concert. Outside, a hard, sharp rim of keratin, the same material as our fingernails. That outer wall is tough and resists wear. It digs into small cracks. It acts like the edge of a climbing shoe, letting the goat stand on the tiniest ledges. Inside, a soft, pliable, slightly concave pad. The pad has a rubbery texture, like a high-performance sneaker sole. When the goat weight lands, the pad presses down and deforms. It molds to microscopic irregularities of the rock, maximizing contact area, which then maximizes friction. The mountain goat's hoof has another secret weapon hidden in plain sight. It is a cloven, or split, hoof. The two halves can move independently. This creates a pincer-like grip, dramatically increasing stability and friction. The goat isn't just resting, it's actively grasping. Independent toe movement also improves weight distribution. The toes adjust to different angles, so both soft pads make maximum contact. This dual material design is evolutionary genius. An all-in-one solution. The remarkable external features of the hoof are supported by an equally remarkable internal architecture. It is connected by a complex, interlocking structure known as the laminae. These two sets of laminae interlock, creating an incredibly strong yet flexible bond, allowing it to distribute the goat's weight and the shearing forces of climbing evenly. Another critical internal feature is the rich blood supply within the hoof. This system allows the goat to precisely regulate the temperature. In freezing conditions, the goat can pump warm blood into its hooves to keep the pads from freezing solid. This internal heating system ensures the pads remain soft and effective even on icy rocks and in frigid temperatures. A perfect set of hooves is useless without the power to drive them. As we noted earlier, the goat is a pull-up climber, relying heavily on the strength of its forelimbs. Its chest and shoulders are packed with massive muscle groups. These muscles provide the immense force needed to haul its body weight vertically up a cliff face, step after step. They are the engine of the climb. However, brute strength alone is not efficient. To solve this, the mountain goat's legs are equipped with extremely long, strong tendons. They act like biological bungee cords or powerful elastic bands. When the goat lands from a jump, these tendons stretch, storing a significant amount of elastic energy. As the leg extends for the next movement, the tendons recoil, releasing stored energy. This process is known as elastic recoil. This tendon system makes climbing incredibly efficient, allowing the goat to traverse vast vertical distances without becoming exhausted. Underpinning the goat's powerful musculature is a skeleton perfectly adapted for climbing. One of the most important adaptations is found in the shoulder joint. Unlike humans, mountain goats have no clavicle. Their shoulder blades float. This provides an incredible range of motion. This flexibility is essential for navigating the unpredictable, three-dimensional nature of a cliff face. The legs themselves are relatively short and stocky. This is a classic adaptation for strength and stability rather than running speed. Furthermore, the joints of the legs are capable of moving through a very wide range of angles. This allows the goat to place its hooves in unusual positions. Our biomechanical tour concludes with an invisible but vital system, the goat's sense of its own body in space. This is called proprioception. It can feel the subtle shift of a loose rock. If a hoof does start to slip, the proprioceptive sensors detect the unexpected movement and trigger an instantaneous reflex arc. Before the conscious brain even has time to register the problem, signals are sent directly back to the leg muscles, in a way that corrects the slip. These reflexes are the goat's safety net. It is the control system that operates the living machine, turning the sheer, unforgiving rock face into its own personal playground. Life in the high mountains is physically demanding and nutritionally challenging. Vegetation is often sparse, scattered in small patches. They are herbivores, primarily browsers, feeding on a wide variety of alpine plants. Grasses, herbs, sedges, ferns, leaves, and twigs of low shrubs and lichens scraped from rocks. Like cows and sheep, mountain goats are ruminants. They have a complex, four-chambered stomach designed to extract maximum nutrition from fibrous plants. The rumen acts as a large fermentation vat, filled with a rich brew of bacteria and protozoa that break down cellulose, a compound most animals, including humans, cannot digest. The goat can quickly graze a patch of vegetation and then retreat to a safe, inaccessible ledge. There it will regurgitate the partially digested food, cud, and chew it again to further break it down. Rumination. This system is a masterpiece of metabolic efficiency. It allows the goat to thrive on a diet that would be worthless to many other animals. While their digestive system is built to handle tough vegetation, mountain goats have a surprising and unusual craving: salt, sodium, potassium, calcium. These minerals are vital for proper nerve function, muscle contraction, and maintaining fluid balance in the body. To supplement their diet, mountain goats will go to extraordinary lengths to find natural salt licks. This drive for minerals explains some of their most bizarre, death-defying behaviors. In recent decades, this craving created interactions with humans. Roads, especially in winter, become an excellent source of salt. Nowhere is this more evident than Gibson Dam in Montana. For years, observers were mystified by goats regularly appearing on the steep downstream face of the concrete arch dam. They were not just near the dam, they were on it. The dam face became the most reliable, accessible salt lick in their home range. A mountain goat's world is a complex, three-dimensional labyrinth. Survival depends on knowing where to go and how to get there safely. This requires sophisticated spatial cognition and a remarkable memory for routes. An adult mountain goat possesses a detailed mental map of its home range. GPS collar studies reveal highly specific, consistent corridors of movement. They follow the same ledges and cross the same gullies repeatedly. These are proven, low-risk highways. A goat will remember a specific sequence of footholds for a cliff face, sometimes learned years ago. This memory is life and death. This mental map is built over a lifetime. It begins when a kid follows its mother. For its entire first year, a kid is an apprentice climber. The nanny is guide and protector. She's also the climbing teacher. A kid watches its mother negotiate a difficult section, studying technique, then attempts it itself. If the kid gets into trouble, the nanny often returns to guide it or show another way. This maternal instruction is the foundation of the kid's survival. Learning from elders creates cultural traditions within goat populations. Specific routes used to traverse a mountain are knowledge passed down generations. A population might use a difficult pass between two valleys that others don't know. A tradition, collective knowledge held and transmitted by the group. Mountain goats aren't solitary automatons. They live in a social world structured around female-led groups. The shared knowledge is a vital adaptation, as important as their cloven hooves. Our journey has taken us from dusty archives to the highest peaks, from the laws of physics to the secrets of anatomy. We began with a simple question, born from the grainy footage of a ghost on the cliff face. How do they do it? It's not one trick. It's a breathtaking synthesis of countless adaptations. A perfect storm where physics and biology converge. The mountain goat doesn't break physics. It was forged by it, shaped into their principles. The ultimate master of its vertical world. The mountain goat is more than a collection of fascinating adaptations. A symbol of life's tenacity and evolution, finding opportunity in forbidding places. It turned the sheer, barren cliff, a barrier to others, into a fortress and a refuge. Here, on the edge of the world, it is safe from most predators. Dr. Evelyn Reed's ghost on the cliff is no longer a phantom. We can understand it in exquisite detail. That understanding deepens the wonder. We leave with renewed appreciation for these masters of the mountain, a living, breathing work of art. The view from the summit. We have journeyed alongside the mountain goat to reach this summit of understanding. We have seen how this incredible animal transforms the hostile vertical world into a safe and prosperous home. These animals are a vital and inspiring part of our planet's natural heritage. Their continued existence depends on our respect and our commitment to preserving the pristine mountain ecosystems where they make their home. The process of discovery never truly ends. If you found this journey as fascinating as we did, please take a moment to show your support. Giving this video a like helps us reach more people who are curious about the natural world. And to make sure you don't miss our next documentary, be sure to click the subscribe button and turn on notifications. We have many more secrets to expose and many more adventures to share. Thank you for watching, and we'll see you on the next one.